Hi, my name's Lucian Wishick. I'm telling you 3 essential tips for how to program async correctly. This is the first tip that we've come across. Async void is for event handlers only. I'm going to motivate it with a customer story. This customer, let me read out what she said. She said, I've got a picture of her code. I have a Silverlight page that uses RIA services async to load the data for the page. This works, and she could select different months or different sales zones. She said, this works fine if the user waits for a few seconds before selecting the print button, but it does not work if the user clicks print straight away. If the user clicks print button before all the page data is loaded, then the printed output doesn't have all of the data. Well, the diagnosis is that she was returning a void from her async method deep inside her code, and she should have been returning task. Let me put that more strongly. For goodness sake, stop using async void everywhere. I should just say, I mean, when we were designing the async feature, we knew that it was unfamiliar. Not difficult, just unfamiliar. And we knew we'd have to educate people about how to use it properly. And this, don't use async void except for event handlers, is the most important lesson. Actually, I don't want to share that user's code because it was a bit involved. I want to show you the code from someone else who made exactly the same mistake. The mistake is that their async method sendData returns void where it should be returning task. This code actually comes from an official Microsoft Windows 8 SDK sample. Just goes to show it's a common mistake that everyone can make. Don't worry, we fixed up the sample. So what happens? The user clicks a button. It invokes the button click event handler, which calls sendData. So control goes straight into sendData, and then it comes to the first await inside this async method. What happens at the first await inside an async method? Well, we normally return a task back to the caller, but in this case we're returning void. In either case, we return control straight back to the caller. This caller has another await. What happens when the control reaches the first await inside the caller? It returns back to its caller, probably the message loop. And then we're in a difficult situation, you know, because what's going to happen next? Is it going to get a response back from the network first? Or is this timeout for task.delay of 2000 milliseconds going to happen first? Well, it's a race condition. Either of them could happen first. You know, if we're lucky, it'll get the data back from the network. It will assign it into this mGetResponse field, which will be shown by the button click handler. If we're unlucky, the network will take longer than 2 seconds and will print this mGetResponse out before it's been assigned. That's why I started this tip with the user quote, "My code works most of the time, but 99% of the time, but not always." And you can just see what happened in this code. The user experimented around with await task.delay of 500 milliseconds. Doesn't work enough. Try 1000. Doesn't work enough. Try 2000. That seems to be working most of the time. They tried to experiment with these numbers just until this code seemed to work on their own internal testing network. Of course, once they deploy it to customers over slow connections, then it's going to fail and they're going to get customer complaints. And the problem here is all down to this async void sendData. It's a void, right? It doesn't return anything to its caller. The caller can't do anything with it. The caller is unable to know when sendData has finished. It's basically fire and forget. That's the crux of this problem, that an async void is a fire and forget. Before I tell you how to fix up this code, I want to show you another problem that stems from the fire and forget nature of it. Let's comment out the problematic thing with this mGetResponse business. And let's focus on exceptions. We'll focus on the try-catch that the user had put around the call to send data. Why did they do that? Obviously, They wanted to catch any exceptions that came out, but it doesn't work like that because of the async void. Let's see what happens. The user hits the button, it invokes the button click handler. It calls this send data method. Control goes into send data. It comes to the await. What happens when we come to the first await in an async method? We return control straight back to the caller, and we've done that. And when we return to the caller, the next thing we do is we walk out of the catch block. No exceptions have been thrown yet, have they? So we plow straight through the catch block and we return to the caller. It's only later on, after the network comes back, maybe after 3 seconds with a network timeout exception or a URL not found 404 exception, which will happen maybe sometime later, that control will return after the await, and after the await, the first thing it does is it will throw that exception. So the exception will be thrown now. It's too late to be caught by the catch block. So what does happen to exceptions that get thrown from async void methods? Well, the answer is that they get posted straight to the UI thread, for the UI thread to handle when it has time. What's it going to do? That varies, you know. On Windows 8, it's going to crash the application. On Windows Phone, it's going to swallow it silently. On WPF, it'll pop up an exception dialog. None of those are what we want to happen in our code, right? So what we've seen is another problem with the fire and forget nature of async voids. The fact is that their callers are unable to handle the exceptions that come out of them. So what are the underlying principles that we've learnt here? We've learnt that async void is a fire and forget mechanism. The caller is unable to know when it's finished. The caller is unable to catch exceptions. Instead, they get thrown straight to the UI thread. And so the guidance here is very clear. Use async void methods only for top-level event handlers and their like, and use async task returning methods everywhere else in your code. There's one other thing I'm going to mention here to do with async void lambdas. We'll come to that in a sec. But first, let's fix up the code. Well, the problem was it was returning async void, and it should have been returning task. So we'll cross out void, we'll return task, and because it's an async task returning method, we give it a name that ends in the name async, send data async. And so the caller up here says send data async. It recognises, hey, it's an async method, I should be awaiting it. So he sticks in the await, and there we can get rid of this terrible await task.delay of 2000 milliseconds. And there we've fixed up the code. You know, I could have made it even nicer if I called this async task of string, and instead of assigning it to a field, I just returned it directly. That would have been good. Well, that was easy enough to fix up that simple case. We've said that async void is for fire and forget, and the only place that async void is appropriate is for event handlers or event-like things. What do I mean by event-like things? Well, let's look at this case. This one's going to be a bit more tricky, but the same principles apply. You know, I was actually wondering how bad is the problem of people misusing async void. What I did was I looked at MSDN forums, I typed in async void and problems just to see how many people were hitting problems with async void. And what I hit the most of the time was async void load state. I wasn't familiar with that, maybe you're not. So I dug into it. It comes from Windows 8. Let's focus on the code and see how it works. Well, it starts with Navigate to. Windows 8 apps, they're based around pages. When you navigate to a page, it fires the Navigate to event. And the base class that we always inherit from this layout aware page has an overridable void method called overridable void on navigated to, which handles the navigated to event. So on navigated to, even though it's an override method that we do, it's used pretty much like an event handler, and so it's appropriate for us to have async void on navigate to. Well, we're object-oriented, the first thing we do is we invoke the base method, base.onNavigated2. I had no idea what this does, so I looked it up. In the base class of our Windows 8 pages, in the base implementation of onNavigated2, it has a little bit of code. The meaning of the code isn't important. What's important is that the first time we navigate to a page after it was constructed, we're going to call this load state method. It's a void, overridable void load state. And it will be fine the first time we navigate to it after the page has been constructed. So basically, load state is also a bit like an event handler, you know. It's also fire and forget, happens on the first navigate to event after page construction. So we'd think it's okay for it to be an async void. Maybe by now you can tell where this code is going to run into problems. But let's step through step by step and see what happens. So the user navigated to the page for the first time after it had been constructed. The method override void onNavigated2 calls base.onNavigate2. Ultimately, control will flow into our override async void load state. What we're doing here is we're loading a bitmap from storage so we can display it. So, as always, it's await until we get the file from disk. What happens at the first await inside an async method? Answer, control returns back to the caller. In this case, the caller does another await, so control returns back to this caller. But this is looking very familiar, isn't it? We have a race condition. We don't know which is going to happen next. We don't know if we're going to be able to assign the source to the bitmap, load the image into the bitmap first, or are we going to try and use the bitmap first? It's the same problem as we had before. And remember what the solution was before? The solution before was not to use async void inside the code. Instead, it was to use async task returning methods. So async task load state async. But we can't do it in this case. Why can't we do it? Because load state, overridable void load state, is not under our control. It's part of the template there. We cannot change its return signature. So we can't do our normal trick of returning task from this async method. Instead, we're going to have to return a task some other way. I'm going to show you how the code for that works. Let me just tell you how I recognize this problem. Whenever people on the forums ask, hey, pixel width is 0. We were using pixel width in this code. We were using it to try and position our image correctly based on its size. They say pixel width is 0. Why is pixel width 0? It's because they were trying to read from the bitmap before it had finished loading. So a complete classic race condition. So how are we going to fix it up? Well, look inside this load state method. It's still override void load state because we can't change the signature, but we're going to call load bitmap async. This other routine that we wrote, it's an async task returning method. And what we're doing is that we're not invoking it fire and forget. We're doing the complete opposite. We're remembering it. We're remembering the task that we got back inside this bitmap task field. I've defined it as a class level field. And what that means is that inside the onNavigated2, we can await for the bitmap task to be finished, and then we can proceed getting its pixel width just fine, and the race condition will go away. So that's the long and short of it. Don't use async voids inside your core of your program. Instead, make sure you return task, either directly, or if the framework doesn't let you do it, you'll have to figure out your own way to return a task. Well, there are lots more places where this basic lesson applies. I put up the slides on blogs.msdn.com/Lucian. These are going to be hidden slides that I'm not going to go in this Channel 9 talk. You can also download the slides from Channel 9. I talk in more depth in those slides about other places where people run into async void, like in constructors, property getters, and so on. But there's one important place that I want to draw your attention to with async voids. This is a surprising place where they're going to bite you. The thing is that in C#, when you write an async lambda, it can be either void returning or task returning. Let's look at this code. I've got async lambda. Inside it's got an await statement and an assignment. In the first line, I assigned it to action, which is a void returning delegate. In the second line, I assigned exactly the same async lambda syntax to a task returning delegate. Both of them compile completely clean. In other words, in C#, an async lambda can be either void returning or task returning. And the question is, which? Here, look at this code down here. I did await task.run, and I passed exactly the same async lambda inside. Well, what do you think it's going to be? Is this going to pick void returning, or is it going to pick task returning? You know now why this is such an important question, because the void returning asyncs run into a whole host of problems. Well, the quick answer to this is that if both overloads are offered, if it offers both a void returning and a task returning overload, it will pick the task returning overload. And that's good, and that's what we wanted. In Visual Basic, the situation is slightly different, but we end up with the same overlying principle. In Visual Basic, it's not the context that determines if it's going to be void or task returning. Instead, it's the syntax of the lambda itself. Here I wrote async sub, so this is going to be a void returning async lambda. Here I wrote async function, so this is going to be a task returning async lambda. But the punchline is exactly the same. If both overloads are offered, it will pick the right one. Well, you should give it the task returning async function lambda, and if you don't, it will tell you off and say, hey, you probably meant to give it. But in C# and VB, if ever you have invoked something that doesn't have both overloads, has only got one, then you're going to run into trouble. And here, I've picked an example of some real-world code where we do run into exactly that trouble. Let's take a look. Here we're using dispatcher.run async. I'm sure all of you who have done UI code and Silverlight, Windows Phone, Windows 8, WPF have used dispatcher. It's for doing work on the UI thread if you currently are on a thread pool thread. And what I see here is that there's an async lambda. Now, forget about everything else. As soon as you see an async lambda, straight away, alarm bells ring in your head. You're thinking, async lambda, is that going to be void returning or task returning? Let's have a look which. I'm invoking dispatcher.run async. I've never seen it before, so I hit F12. I copied out what it says here. Run async takes an argument called dispatch handler. I've never heard of this dispatched handler delegate type. I hit F12 again. I see, aha, it's delegate void dispatched handler. So this lambda is going to run into the troubles we've been talking about all along. This is going to be an async void lambda. What's going to happen? Well, let's suppose we do dispatcher.run async. Dispatcher is going to start running the code. It will come to the first await inside this async lambda. You know what happens when we come to the first await inside an async lambda? Well, it returns control straight back to its caller, returning either a task or, in this case, a void. So dispatch.run async gets back the void. It doesn't know any better. It thinks the lambda has finished. Watch this. It's going to continue the code. It's going to think that it's finished. It's going to come to its await will finish, and it will plow straight back through its catch, through its finally block. It's going to have exactly the same problems that we saw before. It's not going to catch mResult in time. It's not going to catch the exception in time. So, what have we learned? What we've learned is that async void is a fire and forget mechanism. A fire and forget means that the caller is unable to know when an async void is finished, and it is unable to catch exceptions that get thrown from an async void method or lambda. The guidance, we said, use async void only for top-level event handlers or for things that feel and look like top-level event handlers. iCommand is another case of that. And use task-returning async methods everywhere else. Also, whenever you see an async lambda, verify it every single time. Verify whether it's going to be async void or async task. That's my first essential tip for using async correctly. I hope you enjoyed it. Thank you.